Hi students, welcome back. So now we are going to make a weather station. So what exactly is weather station? So we are going to monitor and display few environmental parameters. In this we are choosing 4. You can always have more or less. So these parameters are light intensity, temperature, poisonous gas level and the status of earthquake at that place. We are going to send this data to PC as well as on an LCD so that it can be displayed or used or processed. So we need some components, Arduino, sensors like gas sensor, LDR, tilt sensor and temperature sensor, each of them for their respective parameters. LCD is optional and few resistors. So here we are having a new sensor called tilt sensor. Other three we had already studied. So what is this tilt sensor? It's a digital sensor to detect if the surface of sensor is tilted or not. That means it is perfectly horizontal or it has been tilted towards the vertical level or not. It will give you true or false value and it will be used to detect earthquake in this project. It is not a sensor to detect the earthquake, but we are just going to use it in a way. Let us see how. So this is a tilt sensor where you can see there is a metallic tube on one end. There is a liquid in this tube, and if it is horizontal the connection between two pins is not there, and if it will be tilted you can see that two metallic pins, they can get connected or shorted and I can get the output as 1. We are saying when there is an earthquake this sensor is going to shake or possibly tilt, and then it is going to give us the signal that yes, there is an earthquake. So not exactly an earthquake sensor, but can be used as earthquake sensor. So let us look at the complete project now. Here we have gas sensor which we already know, and for different gases we have different gas sensors. The output of this is going to one of the analog pins. Next I have a tilt sensor. It is a digital sensor, so the output is going at pin number 4. Next we have temperature sensor. We have studied LM35, the temperature sensor, and the output is going to an analog pin which is A2. Here we have LDR. You could have used light ambient sensor also, which is for detecting the intensity of the light, and this is used in series with another fixed resistor, and the output of this voltage divider circuit is going to one of the analog pins, and that is A0. LCD is optional. You can have it for displaying the parameters for public, and all the data is being stored and can be processed by Arduino to trigger additional alarms or generate more messages. So now we are going to check this circuit on Tinkercad. So we have our circuit here. Now let us look at the code. So we have sensor value 0, temperature value which is my temperature pin. So where is temperature connected? A2. Earthquake pin is pin number 4. This is the tilt sensor. Right now the status is 0. MQ2 is my gas sensor and that is connected at A3. Okay, so this one which is connected at A3, this is my gas sensor. Then initially I am saying the value of gas is 0. I am using LCD, so I have to include the LCD library and mention the sequence, so which is pin number 12, 11, 5, 7, 3, 10. It is different from the usual which we used to take, so be careful whenever you attach the LCD. So here now how am I going to start? So I have this setup function where I say serial begin, serial communication. A0 is my input pin. A0 is this one which is from the LDR. Pin mode, switch pin as input. What is switch pin? Here you can see that switch pin is defined at pin number 2. Okay, now coming to the loop, I say earthquake status. Quake status is digital read of quake pin, and then go to a function which is auto switcher. So what are we going to do? We are going to display one parameter at one time, and first I display one parameter, let us say light intensity, then for next second I display next, then next second I display next. So that is for the display purpose, and if I have to take some decision I can take in between. So this auto switcher function is going to go from one to another parameter. So where is this auto switcher function? You can see this is my auto switcher function. I am saying LCD print cycle modes. That means it will keep on going in a cycle. 1 second delay, clear the LCD and keep counting. So now when the counting is happening, it will start from 0, 1, 2. When it is 2, go to the function which is brightness for 1 second, then clear the LCD, increase the count. So the count which was 2 will become 3. Then it will go to this condition if count is 3. Then it will go to a function called temperature. Display or do anything in the function of temperature. Clear the LCD and increase the count. Once the count is increased, we will go to 4. In the 4, I am working on a function which is related to gas. Do everything in that function, come back, clear the LCD, increase the count. So now the count is 5. Now I am going to quake. Do everything from quake function, reset the LCD, increase the count. And when the count is 6, I am saying clear the LCD and go back to count 2. Count 2 means this. So that means this 4 will keep on repeating one after another in a forever loop. Now what are these individual functions? Let us look at them. So the first one is brightness. Brightness is coming from this LDR and the values will be between 0 to 1023. Now you can decide which is very low brightness, which is medium brightness, which is very high brightness. Brightness values, once they are recorded, then I can say okay, serial print the value. This is my current value of brightness. If it is less than 600, I will say it is dark. If it is between 600 to 700, I will say it is comfortable lighting. 7 to 800, I will say it is a noon brightness. And if it is very high, then I can say it is way too bright. So simple, we are not doing anything, we are just displaying that what is the level of brightness at this moment. If I have the next function which is temperature, I am going to analog read the temperature and I am going to convert that value into degree Celsius. To convert that, I use this formula, and there was a biasing of 49 or 50 degrees. I have subtracted that because when you are converting, what is temperature sensor here? It is giving electrical value and that is being read at pin number A2 as a integer. So it will be a number between 0 to 1023. Let us say at 25 it is giving some number, at 35 it is giving some number. So we take all those numbers and by linearly scaling and matching them to the correct degree Celsius value, this is the value which we got as our scaling factor, and this was the biasing. So now I can get my temperature in degree Celsius. So I will print the temperature in degree Celsius. If you want to convert that into Fahrenheit, you can just adjust the values here. Now I will say serial print temperature in degree Celsius. If you want to do something with the temperature, whether it is very high or very low, and you want to generate some messages, you can do that. Earthquake, we are reading from the quake pin. If it is low, we say earthquake, else we say no earthquake, right? So that is simple decision. And again, you can generate additional messages if you detect an earthquake. In the gas sensor function, we are saying read the value in this variable sensor value from analog pin A3. If it is more than 400, we say smoke detected, or if it is for any other gas like carbon monoxide or any other harmful particle, you can mention that this particle or this gas is detected, and you can print it. Otherwise you say gas value is this much and you are safe. You can print it on LCD, you can print it on serial monitor, or both. All the options are available to you, and that is the whole code. Now let us see how does this program work. So here is our LCD. Here are the four sensors. We need to keep an eye on the serial monitor as well, and now we start the simulation. So you can see this is cycle mode. It's dark, temperature is this, gas value is this, no earthquake, and it will keep repeating. It will keep on repeating these. If you change any value, okay, if you tilt the sensor, I have tilted it. So when the term for earthquake will come, then it will say earthquake. Okay, it will not immediately say, because it's a weather station. One after another, it will show all the parameters. So here I bring it back. Temperature, which is 25, I am increasing it. I have increased to 67. Okay, now you can see it is showing 67. Whenever the term for temperature will come, it will show. Here is the brightness level, and right now it is showing it is dark. I bring it slightly on this side and it is saying way too bright. That means I have not configured this sensor correctly. So if I come here, it will show way too bright. So you should configure and optimize your sensor values correctly. So here it is dark, slightly this side, comfortable lighting. So this way, now you can realize that you can add more sensors, more actuators, more processing into your project and make it an actual real-time weather station. So I am sure you have learned a lot from these mini projects, and you are going to work on a lot more. We have a module test coming. Keep learning. Thank you.